Assalamualaikum and hi everyone. My name is Wan Izzah Atira binti Wan Kamaruzaman, matric number D201910888446. So, today I will share with you guys about a learning video about Carnot heat engine or Carnot cycle. Stay tuned. Okay, before we start our learning, I want to ask all of you if you ever wonder how refrigerator works and how refrigerator become cool and why at the back of the refrigerator we feel so hot. All of you must be wondering, right? Okay, let me explain how refrigerator works. Refrigerator contains four major components, which is compressor, condenser, expansion device or metering device, and evaporator. Refrigerant remains piped between these four components and contain refrigerant loop. For the first step, refrigerant begins as a cool vapor and head to the first component, which is compressor. We can consider compressor as the engine for refrigerator. It forces the refrigerant through the system, which is through the refrigerator. In the process of being compressed to cool, gaseous refrigerant is turned to a very hot and high pressure vapor. After compression, the refrigerant moves to the condenser. Condenser turns the refrigerant from hot to cool in a form from gas to liquid, which is condensation process. This happens when warm air is blown across the condenser coil that is filled with hot gaseous refrigerant. This allows the heat to transfer from the refrigerant to the cooler air, where the excess heat is rejected to atmosphere. Then, the refrigerant turns from a vapor into a hot liquid due to high pressure and reduction in temperature. Next is expansion device. Expansion device is responsible for quickly driving the pressure of refrigerant down so it can boil more easily in evaporator. As we know, when pressure drops rapidly at the expansion device, the refrigerant turns into a combination of a cool liquid and vapor. The last process is evaporation. Evaporation, where it is for cooling the air going to the space by boiling the refrigerant. This happens when warm air is blown across the refrigerant, which cool air directly before it is released to the space. The low pressure liquid refrigerant is easily boiled by the warm air blown across the evaporator and head back to the compressor as cool vapor. So, this is how refrigerator cycle works, and yes, it is same with what we will learn after this. And yes, I know some of you might be like not understand at all about how refrigerator work, but I will explain after this about a Carnot cycle, which is more easier to understand. Okay, so this is our topic for today, Carnot heat engine or Carnot cycle. A Carnot heat engine is a theoretical engine that operates on the Carnot cycle. Every thermodynamic system exists in a particular state. A thermodynamic cycle occurs when a system is taken through a series of different states and finally returned to its initial state. In the process of going through this cycle, the system may perform work on its surroundings, thereby acting as a heat engine. A heat engine acts by transferring energy from a warm region to a cool region or space. The cycle may also be reversed. The system may be worked upon by external force, and in the process, it can transfer thermal energy from a cooler system to a warmer one, thereby acting as a refrigerator or heat pump rather than a heat engine. So this is the diagram for the Carnot engine. So this is the Carnot cycle, and this is the graph for the Carnot cycle, which is graph of pressure against volume. There are 4 processes in the Carnot cycle. The first one is reversible isothermal expansion. Second one is reversible adiabatic expansion. Third one is reversible isothermal compression. And the last one is adiabatic compression. Okay, for the first process, it's reversible isothermal expansion. And from the graph, we can see this process from point 1 to point 2. Okay, isothermal. Isothermal means no change in temperature or temperature constant. So what happened here is that heat energy from the heat source is transferred into the gas and result the expansion of a gas, which then increasing the volume and decreasing the pressure. As we can see, the pressure will decrease. The next process is reversible adiabatic expansion. Okay, adiabatic. Adiabatics means there no heat transfer between system and surrounding. And according to this graph, the process is from point 2 and 3. So what happened here is the entropy becomes 0, and on the process the volume will increase. Yes, volume will increase and the pressure will decrease. Okay, the third process is reversible isothermal compression. As you know, isothermal means no temperature change or temperature constant, and this process from this graph is from point 3 to point 4. And so by compression is mean volume will decrease. Yes, as we can see in the graph, volume will decrease, and as a result, when volume decrease, the pressure will increase. And yes, we can see the pressure is increased. On this process, heat energy from gas is transferred to the heat sink, or it's mean by heat will be out to the atmosphere. Okay, to make a Carnot cycle complete, we need the last process. The last process is reversible adiabatic compression. And from this graph, of course, the process is from point 4 to 1. Okay, since it's adiabatic, so all change in temperature is contained within the system. So it's mean by the temperature change only occur in the system, and the entropy is 0. And as we can see, the volume is decreased. Yes, the volume is decreased like this, and the pressure will increase. Yes, the pressure will from here and up here. Okay, so this is that makes a Carnot cycle complete. So why Carnot cycle is the most efficient cycle? Let me see. Carnot cycle is the most efficient engine because of the perfect engine, and the cycle is a reversible process, which is ideal gas is the making medium, and the last one is thermal capacity of heat source and heat sink is infinite where no reduction. Okay, so here this is the formula for us to find efficiency. Efficiency means the formula heat out over heat in, means heat out divided with heat in. Heat out here means work. Work here means hot heat and minus with cool heat, and Q1 here means hot heat, and after we divide it we can get 1 minus Q2 over Q1. Q2 here is cool heat and Q1 here is hot heat. Okay, Q2 Q1, we can simplify it as T2 T1, and yes, after we change it we can got formula for the efficiency is 1 minus T2 T1. But after we as we know, T2 is smaller than T1, so when 1 minus T2 over T1 we got fraction. So when we got fraction, the efficiency is not 100% at all. So it shows the efficiency is less than 100%, and we cannot get the 100% at all. Okay, this is the example of the question that related to Carnot cycle. Okay, first we read the question. Imagine a Carnot engine that operates between temperature T1 and T2. The engine performs 1200 joule of work each cycle. What is the efficiency of the engine? And the second one is how much energy is extracted as heat from the high temperature reservoir every cycle. Okay, to solve the question for A, this is the easy question, which is efficiency. To find efficiency, we just use formula 1 minus T2 over T1. And yes, 1 minus 300K and 850K, it will equals to 65%, which is the efficiency is 65%. And for B is how much energy is extracted as heat from the high temperature reservoir every cycle. As we know, the work for each cycle is 1200 joule. So we use the same formula efficiency, but we use we use the work over Q1. When we divided it, and we can get 1855 joule for the efficiency for the energy. Okay, these two questions you may do with your own self, and I left the answer at my description. Okay, that's all from me. I hope all of you enjoy watching my video and understand what I taught you just now, and hope it will be benefit for you all. Bye bye.